Good morning. This is the video for Calculus Section 2.6, and Section 2.6 deals with inverse functions. Today's topic is just the derivatives of the inverse trig functions, and then the next one will be just inverse functions in general. So you did a little bit with inverse trig functions in pre-calculus, not a lot, but a little bit. As far as the notation goes, there are 6 inverse trig functions, and I have 2 sets here of notation. Either one of these are fine. I will disclose to you that I like this notation better, inverse sine -1 of x. But the book uses this arc sine, arc cosine, and that at least gets the exponent out of play. So I don't know if that's better or worse. So they are interchangeable. But the book uses the arc sine. When it says y equals the arc sine of x, that would be the inverse sine of x. So just remember what really we're even doing here. If I asked you what was the arc sine of 1/2, that's asking you what angle is it who has a sine that's 1/2. And if you remember your unit circle, that I think that would be 30 degrees, because a 30-degree angle, or pi over 6. So that's what an arc sine does. It takes a number and figures out what angle has that. So we don't need that for today. We're just taking derivatives of the functions today. So we have derivatives of the 6 trig functions, which you at this point should know. Maybe you have them all memorized, maybe you don't. You certainly at some point should. Here are the derivatives of the 6 inverse trig functions. And yes, you should know them. Now, having said that, I notice that the order is different. It doesn't down the left say sine, cosine, tangent. It says sine, tangent, secant. And that's on purpose because the ones directly to the right are just negatives of them. So if you look at the sine and cosine, the only difference is the negative sign. The derivative of inverse tangent and inverse cotangent, the only difference is the negative sign. And at the bottom, the derivative of the inverse secant and the inverse cosecant is the negative sign. So while there are 6 to know, there's really just 3 to memorize. And then knowing the other ones, the co-functions are negative. And then you'll notice that these rules, the way they're written, already have the chain rule in them. So the sine inverse of u, you throw the u prime on top. So if it were just this inverse sine of x, it would be, so if it were, let me do this over here. If it were the sine inverse, that's a -1, sorry, of x, it would be 1 over the square root of 1 minus x squared. Like there's the actual rule. And then by making that x a u, like a function of x, sorry, then that becomes a u, and this you just via the chain rule need to put u prime on top. So I think just putting these 6 derivatives will suffice. So all we're doing today is getting comfortable using those, and I've got 4 examples here that I'll do real quick, and then your assignment is, I think, 12 fairly simple inverse trig function derivatives. So here we go. First example says find the derivative, and I put the appropriate formula on the right page so that we'd have it, since certainly we don't have them memorized yet. So y equals the arc sine of 2x. So, sorry, changing my colors here. So that's my u. U is 2x. So y prime would be the derivative of u prime on top, and the derivative of 2x is 2. And then the bottom will be the square root of 1 minus. Now, we got to be real careful. If I just did this, I would argue that's not right. We have to realize that it's u squared, which is 2x squared. So real easy parentheses to miss. And then the only thing I could do to clean that up, maybe, and not that you always have to clean these up, is just, what's that, 1 minus, 4x squared maybe? I think that is as cleaned up as that one gets. So just a real simple use, hopefully, of the inverse trig derivatives. So 1 down, 3 to go. All right, arc tangent. And again, I've got the formula there. So again, here my function of u is 3x, and of course its derivative is 3. So the derivative of the arc tangent of 3x would be no square root here, just u prime, which is 3, over 1 plus, again, u squared. Again, you have to remember to parenthesize again, 3x squared. And then again, I could write that as 3 over 1 plus, 9x squared. And we're done. That's it. These often Don't go very far as simplifying goes. Just do you know the derivatives of the 6 inverse trig functions? All right, that was the second example. Third one is the arc sine of the square root of x. And of course, if you wanted to write this as the arc sine of x to the 1/2, that would make sense because that's how we write, how we've always written root x. So of course, u here is x to the 1/2. I'm hoping you're comfortable knowing that the derivative of x to the 1/2 is 1/2 x to the negative 1/2. So let's find the derivative here. This is, so the formula says it's u prime. That's the derivative of x to the 1/2. So that's where my 1/2 x to the negative 1/2 comes in. And the bottom is the square root of 1 minus, now officially it is x to the 1/2 squared. Well, I think I can clean that up. Can I get my picture out of the way? No, I can't get my picture out of the way. My picture is often in the way. Okay. All right. So now let's clean this up. I'll do two things. First, I'll leave this on top alone for the moment. Certainly, we're going to change that in a minute. On the bottom, I now see x to the 1/2 squared is just x. So now I see it like that. All I did there was I squared x to the 1/2. And now let's deal with the stuff on the top there that I can move to the bottom. And again, my picture's in the way. Okay. So this is, let's see, I need a pen after all that nonsense. So this is 1 over, I would argue that this 2 can go to the bottom as a 2. And this x, the negative 1/2, can go to the bottom as a root x. And then you've got the square root of 1 minus x. And I think that's not an awful way to leave it. But I will remind you that, and I'm just going to write this down, I'll erase real quick, that the square root of 7 times the square root of 2 is the square root of 14. Like I can multiply inside square roots, just reminding you properties of square roots. So you might, I'm trying to think how you might see this in a multiple choice. It might look like, oh, there went my light, sorry. Oh, it's still kicked in. Good. Who needs lights? This is 2, and then if I multiplied root x times root 1 minus x, actually I don't need the parentheses there. I can just use the root sign. Ooh, that's a big eraser. So I can write this as root x minus x squared. And I don't know that that's better or worse, but it's equivalent. Let me get my light back on here. It's equivalent, and it's a way that you might see it. So there was an example of another example of the inverse sine. And then the last example I have is, hey, look, my picture's in the way again. I've got an inverse secant. So again, I put the appropriate formula on this page. And here the u, the function of x, is this. So y prime equals, still u prime on top, the derivative of e to the 2x. The derivative of e to the something is itself times the derivative of the exponent. So there's u prime. And then it says the absolute value of u, what was u here, e to the 2x. And then times the square root of u squared minus 1. Gotta be real careful how this might look when we're done here. That's u squared minus 1. All right. Now, a couple things that you're going to see simplified here that you need to not get confused by. The top I might just write as 2e to the 2x. The bottom, that thing in the absolute value sign, it's worth knowing that the function y equals e to the x, or e to the 3x, or e to the negative x, those are always positive. E to the x looks like this. It's exponential growth. E to the negative x is exponential decay. So it turns out that that thing inside the absolute value is never negative. E to the 2x is never negative. So I could just write that as e to the 2x. And the rule there is if you're absolute valuing something and you know it happens to always be positive, then the absolute value signs kind of become irrelevant. And if you didn't know that, you'd get away with it. But that's where that we're going to do some stuff with e to the x at some point. It's going to be helpful to know that it's never negative. And then as far as what this square root might look like, e to the 2x squared. When I raise a power to a power, I'm multiplying exponents. So I see this as e to the 4x minus 1. So that's how that one might look. cleaned up. So that's it. It's just being comfortable with or being aware of and starting to get comfortable with these 6 inverse trig derivatives. And so there's your assignment, just numbers 23 and 34 on page 186. So that's all I've got. Have a good Monday. Hope everyone's staying healthy. And we'll do the second half of 2-6 tomorrow. See ya.